Okay, hello, assalamu alaikum. Can you hear me?
Assalamu alaikum. Yes, we can hear you properly.
Okay, just wait 1 minute, then we'll start.
Sir, I have submitted all the assignments earlier today. So can you check it out, please?
Okay, so I'll
Give
check
provide me with the
and
feedback.
okay, I'll send you the feedback soon. Okay, after the class, I will send you the feedback. Okay, so we will start this session. So after completing the 3 hours live training, then we talk about the problem solving for previous class. Okay, so if you face any problem, then we'll have to discuss about this problem also after completing the 3 hours live training program. Okay, so let me share my screen. Okay, can you see my screen?
Yes, you can see
Okay,
every
fine.
screen.
Okay. So basically today's going to discuss about that mainly filtering and displaying the satellite images. So how we can easily filtering and displaying the satellite images and how to create the satellite composite. Okay. And also create the band combination. Okay. And export the satellite imagery, Landsat, Sentinel, MODIS, or import, filter, reduce, clip, and display the raster data, time series analysis, export any shape file, and also cap about the annual image composite. Okay, so let's go start one by one. And before that, anyone have done idea about the remote sensing? Okay, so if I hope all of you already know about the basic remote sensing, these things. Okay, do you know about this basic remote sensing or not? And you have any problem about the basic remote sensing, then I also try to teach you from the basic level, then move to the advanced. Know about the basic remote sensing or not? First type geometry, then feature collection. Okay, then image and image collection. So today I talk about that. First one I talk about that image collection. Image collection image collection is one kind of data type in Earth Engine. Okay, and another is that it's called the image. So now, what is the image collection? Image collection basically set of images. Okay, more than one image, it's called the image collection. Okay, more than one image, it's called the image collection. Set of images. And what is the image? Basically single image, only for the one image. Okay, and when we make the two image, it's the image collection. One image, it's the image. So we find out the two types of data in GE. So we find the two types, image collection and image. But as well as we already discussed about the another type, it's called the geometry. Then we talk about that your feature. Then we talk about that uh, feature collection. Okay, so basically in the GIS or remote sensing, we use always these 5 types of data in Earth Engine platform. So now we talk about the image collection. Okay, what is the image collection? Set of images. So now let's take the practical example. Suppose I want to work with this imagery. I want to work with this imagery. So this is the one kind of Sentinel-2 satellite imagery. Revisit day 5 days, and we find out total 13 bands. This type of bands I find out in here. Okay, just a minute, 1 minute. So this is the image collection we find out in here. So this is a surface reflectance, okay, imagery. So, and we find out the two types of image: surface reflectance and top of atmosphere reflectance. Okay, so surface reflectance and top of atmosphere reflectance have some common difference. If you check, suppose in this time, when sun is heated on my object and reflect the energy directly reflect the energy directly from the surface, it called the surface reflectance. But sometimes it reflected from the atmosphere. Suppose in the atmosphere, so this it's reflected from the atmosphere, not directly from the surface, then it called the atmosphere reflectance. And what is the surface reflectance? Suppose sun is heated in my feature and directly energy directly come from this feature, so it's called the your surface reflectance. And atmosphere reflectance, it's reflected from the atmosphere, okay, not directly from the surface. So this is the common difference between the surface and also atmosphere reflectance. So we find out the two types of reflectance, so it's called the surface reflectance. And if you check another one, you can check, it's the top of atmosphere reflectance. Okay, this is surface reflectance image, it's the top of atmosphere for reflectance. Okay, top of atmosphere, it reflected from the atmosphere, but surface reflectance is reflected from directly from the surface. Okay, and take the information or take the spectral magnetic information, you take from here. Same process, suppose click on the Landsat. Same.
Sir,
Yeah, please.
sir, can you use top of atmosphere reflectance imagery for LULC?
No, basically for the LULC, it's more better for surface reflectance. Okay, because we want to monitor the surface on the land use land cover, so that's why it's more better. Suppose land use land cover, we can also use the surface reflectance, then LST monitoring surface reflectance. But when you identify, suppose different types of indices, suppose NDVI, NWI, then try to use the top of atmosphere, no problem. But when you monitor directly related to the surface, suppose land surface temperature, LST, then try to use the land surface surface reflectance. Or land use land cover, try to use the surface reflectance. Okay, then we find the more better result. Suppose now I want to check, click on here. If you check, we find out the surface reflectance, top of atmosphere reflectance. So both are the same process when you work. Both are the same process. Suppose I want to work for top of atmosphere, just click. So now it show you the all of result. You can see, first of all, dataset availability. Okay, so this is the time for the Landsat 8, top of atmosphere reflectance data, collection 1, collection 2. So this is the collection. So previous time it was collection 1. Okay, previous it was collection 1, but it also developed collection 2. So after some days it show the collection 3, collection 4, different types of collection, because day by day it's added the different information. So now it's the collection 2 is the update version. So we find out between this time period, okay, our image is available. And this is the data set provider, mainly USGS and Google. So USGS basically one kind of United States geographical survey. It's provide the this type of image information. If you simply search here, suppose USGS Earth Explorer, simply search, it's one kind of website. So from this website we can easily parse, or you can also download the data, different types of data we can download from here. So you can see, so this is another topic for download the satellite imagery. But now this USGS, United States Geological Survey, now it's provide the directly data in the Google Earth Engine. Okay, it's provide in the Google Earth Engine platform. So that's why we are not use this site. But previous time with when Google Earth Engine is not working, then we try to use this type of site to download the satellite imagery. So it take lot of time for the analysis. Okay, lot of, and file size is very high for the satellite imagery. So that's why now we also try to use the Google Earth Engine. Very quickly you can get, you can see this type of imagery you can easily get in the Google Earth Engine data catalog. So if you check the without commercial software, without commercial, basically it's this type of is the commercial we need to use, or sport it's a one kind of commercial software. Okay, also you can see this type of digital elevation model, or also get that all of Landsat imagery we can easily download from the Google Earth Engine. So let's go try to discuss about that Google Earth Engine. But this data provided by this site. Okay, this data in Google Earth Engine, it's provided by USGS and Google. Okay, provide. And this is the snippet ID. Snippet ID basically like as a directory. Okay, directory. Suppose this is the folder directory. So when I go to this folder, then I can access this image collection. Okay, and this is the snippet ID, and if you check, it's a ee.image collection. Okay, ee.image collection, then provide the snippet ID. So now this how I can import the data in Earth Engine platform. Very easy. Just you can just copy this snippet ID, just copy, and then paste on your code editor. Just I copy. So now you just define a variable name. So how we can define the variable name? Very easy. Before the name, just use the var keyword, var, and then put the variable name. You can put any name as a variable, any name. I put the name, suppose L8 equal. So now this image collection, it is stored in this variable L8. Okay, and if you check, it's the image collection. And what is the image collection? Set of images. So this directory is stored all of images, not for the single image, because it's an image collection data. So now I want to check how many images are available in this collection. In this collection, how many images are available? I want to check. So let's go. For that, just use the print function. I want to print the L8 because L8 is stored this image collection, and use a function. Just a minute, I connect my laptop charger. Just so I want to check how many images are available in my collection. So just use here the dot size function. Okay, so now it's computing how many images are available. Run the code. So now you can see it in the console tab, number computing. So now it's computed how many images are available in your collection. So anytime, suppose you have a collection, image collection, you want to check how many images are available in this collection, just use the same process. Use the size function. And another thing is very important. You can also find out, suppose click on the docs tab, and you can check ee.image collection. ee.image collection is one kind of data type. So in this data type, I can apply all of function. Okay, in the all of function, only used for image collection data type, I can easily apply. So if you check, this is my image collection, and I apply the size function. Now let's check size function is available in this section or not. So let's check. We try to check it. So where is the size? You can check where is the size. Size function. Okay, so all of function are available because size function I can use in the image collection. So this size function is also available in this section. So in this section, all of function I can use for the image collection data type, or use for image collection for the different purpose. Suppose if you check what is the size, click on here. So you can see this size function return the number of element in the collection. So in this collection, how much images are available, it show you these things. Okay, so we find out very large number of image collection. Okay, so this is the total image collection are available in here, in this directory, or in this snippet. Total, this is the large number of image collection. Okay, we find out. And time period, what is the time period for this image collection? So we can check it from here. This time period from year of 2013 to 2025 08/18. So between this time period, how many images I find out in the Landsat 8 collection 2 tier 1 top of atmosphere reflectance. This is the total number of image collection globally. It show the globally. Okay, so now this is my full image collection, but now this image collection I want to filter. Okay, and choose for a specific boundary, a specific shapefile, a specific area, or a specific geometry. So this image collection I want to filter, and this image collection I need for a specific geometry. So how I can filter? So first of all, I will just explain this theory. First of all, you remember where you need the image, where you need the image, where you need image, or where you need the image. So say something, right? Where you need the image. Second, how you need this image. Then when. Okay, so just use where, how, and when. We simply filtering our image collection. So this is my image collection. It show you the result for globally all of the whole earth. I find out this the number of image collection, but I don't need for the whole earth. I need this image only for a specific study area. Where I need this image, suppose I need the image in, suppose, Dhaka city, or any specific ROI, no problem. Okay, and suppose let's go try to check it. So this is the total number of image collection for the whole world, but I need the image only for Dhaka city boundary, only for Dhaka city boundary. So how I can filter? Just simply upload your Dhaka city boundary shapefile. Okay, or you can simply, I simply show you that from my asset. So I already imported the shapefile. So just click on the asset tab, and if you check where is the Dhaka city, so here I already uploaded. So let me check where is the Dhaka boundary. Dhaka. So this is my asset. I already uploaded this shapefile. Okay, just click on this, click on here. So now you can see a new line of code added in here, table. Okay, so this is the table, and this table, it the default variable name, if you check, it show the feature collection and show the table. Okay, so you can put any variable. I put the name, it's my ROI. So now for this ROI, I need this image. Okay, for this ROI is stored in my shapefile of Dhaka city. So for this ROI, I need this satellite image. So for that, how I can filter? So just use a function. You can check this function called the filter bounds function. So I'll show you the function first. Filter bounds, you can check. So this is function, filter bounds function. Mainly it's shortcut to filter a collection by intersection with geometry. In this case, my geometry is Dhaka city. Okay, and I have this collection. Large number of collection, but now I want to intersect with my geometry and check how many images are available in the Dhaka city boundary. Okay, so I need to use the filter bounds function. Just I copy filter bounds, and now if you want, you can take the another variable. So I'll show that, take the another variable, it's more better. So I take a variable, suppose filter region. You can put any name as a variable, and then I call the L8, because this L8, this variable L8, it is stored this large number of image collection for the whole world. But now I want to need this image, I want to intersect with my geometry. This collection I need to intersect with my geometry. So for that, just apply a function, filter bounds function. Okay, filter bounds function. And what is the argument? If you check, what is the argument? Geometry. Okay, what is the geometry? Geometry basically point, line, or polygon. In this case, my polygon mainly my shapefile. This shapefile is stored in the ROI, so just call the ROI. Just put here ROI. Okay, done. So now this variable is stored only for those image which image is intersect with my boundary. So let's check how many images are available. So print, just I call the filter region to check how many images are intersect with my study area. Size function. Now run the code. So we find out the 489 images intersect with my study area. And what is the time period? On this time period is between this time period 2013 to 2025. The whole time period in the Dhaka city, how many images I find out? Total 489 images. So now how? Suppose from this 489 images, I need only for those images, which image will be not more than 1% cloud covered. So it's called the filtering image metadata. Image metadata. It also called the image properties.
Sir, I have a doubt.
Please.
Sir, instead of filter bound,
Yeah.
why not we use cliff function?
Okay, so these are totally two different function. And if you check in the ee.ImageCollection, so it's not the theoretical, but I'll show you that. You can see ee.ImageCollection. If you check, in this section you don't find the clip function. If you check, you can check one by one all of those. Let me check. Where is the clip? There is no clip, I think. Yeah, if you check. Clip is not available because we cannot use the clip for the image collection. Okay, clip is only work for image data. Okay, clip is only work for image data type. Okay, this data type is only work for clip function. Image data only work clip function. Okay, so why clip is not working here? So clip, this data, this function is only work for image, not image collection. So if you can see, I just use the clip, then check what happened. Clip. So now run the code, it show a problem. You can check, just run the code. It show that clip is not a function. It means that clip is only work for image data type, but now you try to use the image collection. So L8 is the image collection, not single image. It's a more than one image or set of images. So that's the reason clip is not work in here. Clip is only work for the image, only image, single image. Okay, so now we just use the filter bounds function. It mainly intersect this collection for my study area and find out how many images are available in my study area. Okay, because in the image, you can also check about that. In the image collection, this section, you don't find the clip function. You can check, there is no clip function in here.
Got it.
But if you check suppose image, this is another data type. So now let's check clip is available or not in here. So in the list you can check. So the clip is available in here. If you check, where is the clip? Yeah, clip. Okay. So this is another technique to use the function of Google Earth Engine. Suppose in this time this clip function is available in this section. It means that I can use the clip function only for image data type. I cannot use it for image collection. Same process, size function. This size function I can only use for the collection. Okay, if you check in the image section, there is no size function. You can check, there is no function about the size. Size function is only available for the image collection section or feature collection. Okay, it's only work for the collection. So that's why in this section you find out the size function also. You try, suppose you have an image, you try to apply the size function, then it show that size is not a function. We find out this type of problem in here. Okay, so we find out this type of result. So now we find out the 489 images. It intersect with my study area of Dhaka city boundary. And now I want to filtering the image metadata or image properties. So image properties, it can be different types of property. Suppose cloud cover, you can easily get all of properties. You can check the image properties. Cloud cover land, collection category, then collection number, then data source elevation. Okay, also you can see the data source, different types of data acquisition time. So different types of properties are available, and this type of properties were used for the different types of purpose, but commonly were used at the cloud cover or cloud cover land. So we try to use suppose cloud cover. Just I copy this property. So now I want to check, suppose from 489 images, I need only for this image which image will be not more than 1% cloud cover. Okay, so I simply filtering the cloud cover property. So for that, which function I need to use, let's check it. It's called the filter metadata. Okay, but this function you can see okay, this is the very important thing, is that you can see it show the red color, other show the another color, it show the red color. It means that this function deprecated. Previous time we also use this function, but present time we also use the another function, but it also work, there is no problem. But present time we also use the another function for the filtering the image metadata. So now let's check this function. So this function it show the deprecated. So use the filter, and we put the e.filter equal or e.filter the greater than equal, we use it instead of this function. But this function is also work, there is no problem. And if you check, this function have the three argument: name, operator, and value. So what is the name? Name basically image properties name. Okay, property name, property, which property you want to filter. I want to filter cloud cover property. Then operator, it can be, you can see less than, greater than, equal, or which you need, not less than, not equal, this type of things. And value mainly 1, 2, 3, 4, this type of value. So now from 489 images, I want to filter how many images less than 1% cloud cover. I want to check it. So let's go try to check it, how many images are available. So for that, take a variable. Suppose I put the variable name filter metadata. You can put any name. And now from 489, this 489 image is stored in this variable filter region. Just like copy and paste here. And now you apply the filter metadata, and put the first argument is the property. Okay, your property name, then operator, then value. So I want to use cloud cover, so just use here the cloud cover. Then set operator, I set suppose less than, value 1. So now from 489 images, I choose only for those images which image will be not more than 1% cloud cover. Okay, so let's go try to check it, how many images are available. Same process, just use the print and call the filter metadata and use here the size function. So now it's computing after filtering 1% cloud cover, how many images are available. Oh my god, we find out the only for the 0 image. 0 image means that less than 1% cloud cover image is not available. Why? Oh, yeah, let me check what the problem. Cloud, I put that, you can see, put that wrong spelling. So put the cover, cloud cover. So now run the code. But sometimes you also find out the 0, because when you work with riverbank or any place where all time cloud formation, this type of place we don't find the less than 1% cloud is not available. Okay, so now you find out the 75 images less than 1% cloud cover, and time period is year of 2013 to 2025. but I need this image for a specific month, a specific year, or a specific season, summer season, rainy season, or any specific time period. So now we just work with these things. It's called the when. Okay, when you need this image. So now we are just use another function for the when. Suppose I need this image in year of 2020. Okay, 2020 from January to December 31. Okay, or we can put any specific season, rainy season, summer season, or any season. So now from 75 images, I need only for those images which image will be not more than 1% cloud cover. Okay, so now from the 75 images, I simply check how many images are available between this time period. Okay, so let's check. Take a variable, suppose filter date, and call the filter metadata because this variable stored 75 images. Okay, so these things I want to apply filter date function. Okay, filter date, and if you check the what is the filter date, we can get the filter date, start date and end date we need to define, and filter date shortcut to filter a collection by date range. You can put any date range. Okay, simply put the date range. Suppose I put the date range in year of 2020 January, 1st January from year of 2020 December 31. So now let's check how many images are available. Okay, so print, call the filter date, and use the size function. So now let's check on the code. Okay, I think I'm networking issue. Just a minute. Let me run it again. Okay, networking issue. Just a minute. Can you hear me? Hello. Okay, hello. Okay, can you hear me now? Yeah, can you hear me? Hello.
Yes, sir. We
Okay,
can
so
hear
let me
you.
share my screen again. Yeah. Okay, so I continue. So okay, so now we just try to check how many images between this time, 1st January to December. We find out that only for the 7 images. Okay, we find out that this 7 images is available between this time period. So you can check first time we find out the very large number of image collection. Okay, then we filter for our study area. We find out it. Then we filter image metadata less than 1% cloud cover. We find out, and finally a specific time for year January to December 2020. 2020 we find out that's only for the 7 images. Okay, so this is the process for filtering your image collection. So now we also try to filter any image collection using this process. Suppose you can check the Landsat have different types of image collection. Top of atmosphere you also try. You can also try, suppose you can see the Landsat 9, you also try Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5, you also try. Same process for filtering for, and you also try for the Sentinel also. Okay, same process, just apply and filtering the Sentinel to satellite imagery also. Okay, so also try to practice this type of things also. So now I want to check the information. So I want to check the information. Suppose this 7 image information I need to check. Okay, all of information I need to check. All of properties I want to check for this 7 images. So how I can do it? So just simply print and call the filter date, this variable. Okay, because this filter date, this variable is stored at the 7 images. I just simply run. So now it gave you all of information about these 7 images. If you check, first of all, it show the image collection. Click on here. We find out the type is the image collection. You can see. Okay, and if you check the feature, so we find out the total 7 images. Okay, 7 images. So this is the first image, second image, third image, fourth image, fifth image, sixth image, and 7 images. So now let's check the information. Click on here, and you can see that this image, this is the image type. Okay, this its type is the image. Okay, and if you check the properties, we find out this cloud cover. Okay, cloud cover land, collection category tier 1, collection number 2, data acquisition time November, 11th February 2020. We can get all of information about this image. All of information you can find out for this image. So it's one kind of image we find out. Okay. And if you say the second image, so this is another image, this is the third image, this is the fourth image, this is the fifth image, sixth and seventh image. So I want to display an image in my map. I want to display an image in my map. So how I can display this map? So for that, if you check the image section, where is it? You can check. Yeah, so image data type. So I want to work with the image. Basically, this is the 0, 1, 2, 3. This is the This is the total 7 images. So I want to work with single image. Suppose it's one single image, this is the another image. Okay, so I want to check the image section, and if you check the first function ee.image, so this function an object to represent in Earth Engine image. So when you represent a image, then we need to apply this function ee.image. Okay, and it can be these things, it can be string Earth Engine asset id, okay, or string a number, or Earth Engine asset id and version, or you can see create the constant image. Okay, so we are just use the id, asset id, we need the id, okay, for this image. And if you check, suppose all of image have a specific id. Suppose first image, this is the id, okay, second image, this is the id, third image, this is the id. So every image have a unique id. Okay, I want to display suppose this second image. So how I can do it? Display this image. So first of all, just copy this id, copy this id, just copy, and then call this function. Which function? ee.image, this function ee.image to represent image, and paste this id. Okay, so now I just define ee.image because I would represent a image, and then I simply put the image id. Okay, so now just take a variable name. You can put any name as a variable. I put the variable name, suppose image. Okay, and now if you want, just I want to add the layer and display the image. So we already know about that. Just apply map.add layer function to display the layer. And now what is my object? Anyone can guess it? What is the EE object? I will display the image. So what is my object?
Image.
Yeah, image. So just put here the image and run the code. You can see now it display the layer, but it not focus. So for focusing my study area, we use a function. This function called the map.center object. Same function I apply, map.center object for focusing on my given study area. My given study area is ROI. Okay, just I put here ROI, and I define the zoom level. I put suppose 10 and run the code. So now when I run, it directly focus on my given study area of Dhaka city. Okay, and we find out this type of image styles. You can see it cover. This is my image styles, and this image styles I find out, and it also cover my study area. If you check, suppose just I add the layer for my study area. Suppose I want to add the layer for my shapefile. So how I can add? Very easy. Just add map.add layer. I want to add the layer for my shapefile. Shapefile is stored in the ROI. Just on the code. So now it also draw a boundary. So if you check, so this is my boundary. Okay, this is the Dhaka city boundary, and you can see this image is overlay. It also successfully fill up my study area. Okay, it successfully fill up my study area. So then I can easily apply a function, clip function, clip. So this is the image, and image we can easily use the clip function. Okay, if you check the clip, this is the clip function. It's only work for the image data type. You can check what is the clip. Clip with geometry, mainly polygon, point, line, or polygon. I will use the ROI. This is my study area. So you can clip an image. So I have an image. This image I want to clip with my geometry. So let's go just apply a function dot clip and clip with ROI, because ROI is stored in my shapefile. Run the code. So now we find out the image only for my boundary. But this image is look like that. Okay, so how I can add the visualization, more better visualization of this image? So now we talk about that band combination. Okay, so it's called the band combination. Basically, 3 bands make a 1 combination. Okay. So we are use the different types of band combination. Okay, for the what is the purpose for band combination? Basically, to visualize satellite image in the different way, we are using we can identify different types of feature using the band combination. Okay, suppose for the when you use this band combination, suppose I'll show the one example. Just click on here. It show the B1, B2 and B3 band combination. So I want to set, suppose red, B4 is the red. Then I said suppose B3 is the green and B2 is the blue, mainly RGB, red, green and blue. So RGB, it's called the natural color. Okay, it's called the natural color, or it is also called the true color composite, mainly what the human eye see. Okay, so for the Landsat, we are just applying the band 432, basically red, green and blue. Then we find out the natural color on our satellite imagery. Suppose now I just apply. So now it shows this type of things you can see. But we need to set the wavelength. Wavelength means reflectance value. And now how I can set it? Reflectance value, how I can set. So these things we can set different way. Different stressing level you can apply to set the stressing level. So you can see when I apply the stressing level 98%, it stress the 98% of my image and show the mean and max range for the wavelength value, mean and max range. And now use this mean and max range value and show the visualization. So stressing is one kind of visualization process. So you can see when I put the 90% stress, so it show the another range and display. So for the different visualization, we use the different types of stressing level. So I am to say choose suppose 98%. Okay, stress the data 98%, and it automatically show you the mean and max reflectance value. And now I just apply. So now you find out this type of satellite imagery. Okay, and it's called the natural color or true color band combination. Okay, so band combination in remote sensing refers to the process of assigning different spectral bands of satellite imagery. So in this case, I simply set red, green and blue color to create the meaningful image. So in this time we find out that your true color, okay, naturally what human eye can see, true color. So we find out this type of green color we find out in here. We find out some this type of water body can also find out in here. Okay, so it's one kind of satellite image. So now we simply each band, suppose in this time B4, B3 and B2, each band represent the reflectance value in a specific wavelength of the electromagnetic spectrum. Okay, and by combining them in different ways, we can highlight the specific feature on the Earth's surface. Suppose in this case, I find out this type of feature. I can easily identify this type of barren land, this type of green pixel, this type of place we find out the build up, or it's a water body. So it's one kind of band combination. Okay, and what's the purpose to use the band combination? To visualize the satellite imagery in way that we can use the specific land cover feature. So in this case, suppose I want to put the another example. Suppose I just put here that near infrared, then find out the suppose red and blue. I keep suppose 98% stressing and apply. So now it displays another band combination. So now we find out the red color. So this type of red color indicating about the vegetation, and this type of black color, red color indicating about that your water body. This type of gray color, you can see this type of color indicating about that barren land. Okay, this type of red color, it's a vegetation. So it's another band combination. Okay, this band combination help you to identify vegetation easily. Not only for that, you can simply search on the Google, suppose Landsat 8 band combination. Then you find out the lot of website. Suppose just simply go to here and then you find out the different band combination and also get the idea. So you can see the blue band, green band, red band, near infrared, short wave. So it will show about the range about the east band, micrometer range. We find out also, you can see all of band wavelength and resolution, description, band name. And if you check that, yeah, so you can see 432, basically red, green and blue. It replicate close to what our human eyes can see. Healthy vegetation is green, only flora is brown, urban features appear white, gray, and water is a dark blue or black. This is the another, you can see near infrared, red and green. Okay, then we find out that healthy vegetation show as a red color. Okay, water area. So you can also read this type of thing, then you can get a more better idea about the, this is the another band combination. Okay, this is the another band combination. Suppose I am to apply it 652, basically short wave, infrared one, near infrared and blue. Let's go try to check it. Suppose as I apply here short wave, infrared one, B6, then near infrared and green. I keep this tracing 98%. So this is the another band combination we apply. Just apply. So you can find out this type of place have the vegetation, green color vegetation. This is the water body. Okay, we find out this type of gray color. It show about the barren land. Okay, so this is the image for year of 2020. Okay, but if you check the for the present time 2025, we find out this type of place have the different types of construction work. Okay, already done this type of place, but 2020 there is no. But you also try for present time also 2025 and check the different result, but it's very 2020. Okay, so now we find out this type of place is the vegetation, it's a water body. Okay, this type of place, the barren land we find out in here. And if you check the reflectance value, suppose I check the reflectance value, so click on the respective tab and click, suppose I click on the vegetation, so you can check. Okay, just open. What is the value? Okay, just a minute. So let me zoom. Suppose just click on here. Let me check. It show very high value. I think this is, it's not the reproject the scale value. So let me check the data set. Where use are the Landsat top of atmospheric reflectance. This one, and this is the band. Okay, okay, so what is the problem? Okay, let me run just a minute. Oh, can you hear me? Just a minute. Networking problem. Can you hear me? Hello.
Yes, sir.
Okay, just a minute. Okay, it's working. Yeah. Okay. Okay, suppose I have to add the band combination again. Suppose red, green, and blue. Stressing if 98%. And then apply. So if I know this type of visualization, so this visualization I want to import in my code editor. Okay. So for that, just simply click on here. Uh, Okay, can you hear me now? Yeah. Yeah. So I faced some networking issue. Just a minute. Okay. Okay. Can you hear me now? Yeah. Can you hear me? Hello. Hello. Okay. So let's continue. Yeah. Okay. So now I want to set the band combination. So simply click on here and set suppose red, then green and blue. Okay. Keep the stressing of 98% and apply. Okay. So now it set the visualization only for my map, but I need to import the visualization in my code editor. So how I can import? Click on the import button. You can see. Click on the import. When I click the import, a new line of code added in my code editor. Just copy this variable name and set after the object name. Okay, after the object. So this is my object. So I set it after this object name. So now this visualization is set in my map. Okay. So now if I run the code again, there is no problem. It also set, this visualization is set with my map. So we find out this type of result. So I want to add another visualization. So for that, just same process, click on here again. And I put suppose near infrared, then red and blue, custom stress is 98%. And then apply. So now it shows another band, visualization. So this visualization I need to set in my code editor. So how I can set? Just import. Then new line of code will be added in my code editor. So now I need to add the layer. I create the another layer for this map. So how I can create the another layer? So just use the same, put here map.add layer, map.add layer, and call the image, this variable, this object. But now I want to set the another visualization. This visualization, just copy the variable name and add after the object name. Okay. So now run the code. So now it create the another layer. Okay, so you can see it created the 3 layer because I just used the 3 time map.add layer function. So the first layer it show about that your shape file. Second layer show about the two different visualization or band combination.
Sir,
Please.
how to decide the level of stretching value?
So
Because
it's
you are selecting 98% always. When we will use lesser stretching value? Can you explain?
okay. So this stressing value basically depends on the visualization of your map. Suppose sometime 98% when we apply it, it look more better visualization, and 100% is very high stressing. So suppose you can check randomly, you can check suppose which show the more perfect visualization. Suppose when you add the ndvi map or ndwi map, then we need to check suppose 90% it's look more perfectly showing all of feature, or 98% it show all of feature looks more better. So then we decide which one is more better for visualization. Okay, because it's different. Suppose when I put the 98%, it show the another range. When I put the 90%, it show the another range. But which range is more perfect for visualization, we check it after adding the value and add the map. Okay, so now if I just put the 90%, then it automatically show this type of range and display the map.
So, what is range value here?
Okay, this range value basically
Whether it is a wavelength?
wavelength. Okay.
Okay.
And this wavelength basically it create this three bands combination. Okay, suppose in this time we create the wave east band represent the reflectance value in a specific wavelength ems. Suppose I want to check only for the single band also, I can click on the band. Suppose I want to check only for the one band. Suppose I want to check for the near infrared band only for the one band, and I put suppose stressing 98%. Well, now it show about the only for the wavelength about the b5 I want to display on my map. So just apply. So now I find out only for the near infrared band. Okay, and you can check now it show about the near infrared band reflectance result. So if you check for the check the value, suppose click on this map and check the value. Okay, it show about the all of those. But if you compare the value, suppose I'm going to add the color, it will be more better. Suppose just I add the click on the plated and add the color. Suppose low reflectance value show the blue color. Okay, I add. Then I need to put suppose greater than I need to show this type of yellow color. Okay, then greater than I need to show this type of green color. Okay, so I have to define the green. It show the high reflectance value of near infrared, and blue it show the rare low reflectance value of near infrared band. So now apply. So now if you check compare the result, green color it show the high reflectance value, and we find out the green vegetation. This type of place have the vegetation because vegetation is high reflectance of near infrared. I already write a one comment for the first for the code you can check. So where is it? Yeah, this code you can see. Yeah, you can see vegetation reflect the high energy in near infrared band. So that's why this type of green color, I set the near infrared band, I check. You can see this type of green color is the high energy. So it reflects the high energy for the vegetation in the near infrared band. Okay. So you find out this type of things. Okay.
Sir, but
Yeah.
the wavelength of near infrared varies from 0.7 to 15 micrometer. But here, the range value is from 0.076 to 0.34.
Okay. Near infrared range. What's the range?
0.7 to 15 micrometer. You have already taught us.
Yeah.
Yeah.
Okay. Okay, so it showed the 0.7 to 15 micrometer, but now it showed the very less your 0.007. 0.0
Here
yeah.
in visualization parameter.
Yeah, so these things, yeah. So just I keep the range 98% range, then it shows. Suppose let me check for staging level 2, then 0.09 you can see it show the 0.2. 1, then it show the another 0.1 to 0.1. I keep suppose 100%. It show the 0.06 to 0.3. So basically this range is it doesn't matter, it just show for the visualization. Okay, so we can put in nothing. Suppose I put here the 0 and put the 1, also there is no problem. I put the custom value also. Okay, suppose I put the custom in here 0.7 and put here the suppose 15. Okay, we can also do it, no problem, just apply. So now it show this type of range and visualize, but you can see now it show totally blue color. So this range we find out the blue color. Okay, low. So now we just put the stressing level 98%. So now for my study area, we find out this is the ideal reflectance value for that your near infrared band. Okay, for my study area, and this range is also vary region to region. Okay, suppose when you check, suppose some place it reflectance value 0.3, some place show the reflectance value less than 0.3, so it will be vary region to region. Okay, but it's not the ideal, but for some place we find out, suppose for the NDWI, so NDWI basically, or NDVI, for the NDVI we find out that positive, all of positive value indicating about the vegetation, or NDWI, suppose NDWI all of positive value indicating about the water. So you can check, you can simply put the greater than 0 and identify water, then we find out the some pixel is also mixing, suppose vegetation or others also mixing with the water body. Okay, so that's the reason we need to find out, suppose 0.1 or 0.2 and 0.3. okay, greater than, then we find out the accurate water body we can extract from this satellite imagery. Okay, but this is these things is also different region to region. Some place greater than 0 is work very well, some place 0.1, 0.2, 0.3 it's greater than well. Okay, but it show the visualization. Suppose for my study area, this reflectance value for near infrared is more, this range is ideal for my reflectance area, for my Dhaka city area. So that's why you find out this type of things. But when you work with dense vegetation, more dense vegetation, suppose for any kinds of forest, then this value is also changed, then we find out the more high value. Okay, suppose for the Sundarban or mangrove forest, so this type of things we find out the more high near infrared reflectance value we find out. But this is the common range. Okay, for visualization it also changed, there is no problem. Suppose let me check for another one, suppose for the red, and I want to read, suppose I put these things. So now for the red is the opposite of the near infrared. For the red, if you check, just apply. So vegetation show the low value, so if you check, just apply. So now when I run, we find out this type of place, we find out the blue color. Okay, blue color. So I can check what happened, just apply. So we find out the blue color. Okay, so we find out the blue color because for the red is it show the low reflectance value for the vegetation. Okay, that's why you find out this type of vegetation feature show as a blue color. Okay, but it's generally we are just get the microwave infrared these things, but for it's also vary region to region. Suppose some study area where I have lot of vegetation, then we find out the high reflectance value of near infrared, not only for the 0.3, it also more high. Okay, or some place, this place is not much more vegetation, so then we find out the low reflectance value, suppose 0.07 or 0.0 for the near infrared. So it also vary region to region, it also vary, there is no problem. Okay. Okay, so now we find out this type of result for the only for the single band, but when you make the combination, then we find out this type of combination. Okay, and create the one imagery look like this. I already said it, just run the code. We find out this type of visualization. So now I said the two band combination. This is the near infrared, this is the, and it also called the false color band combination. So if you check now, vegetation show as a red color. This type of place have a vegetation. Okay, this type of place have the water body. So our main purpose to use the band combination to identify different types of feature on the surface. Okay, these are main purpose. As well as I want to add the another one. Click on here. I put here suppose short wave infrared one, then near infrared and green. Stressing I put 98%, keep, apply. So now we find out this type of band combination and we find out this type of result. But this result I want to import. Simply just import. You can see a new line of code added in my code editor. So I want to add a layer for this. Just I take the another. Suppose map dot add layer, call the image and call the another visualization parameter. Just copy and paste. Okay, so now if you check it, show the layer 1, layer 2, layer 3. But if you want, you can also put the name. So how I can put the name? Suppose just put the comma sign and put the layer name. I put it's a suppose I put the name, suppose vegetation. You can put anything, any name. Suppose then I put here it's a false color. Then I put here, so this is a true color. True color. Suppose I do in this case, this is my shape file. I want to add the name also, but I don't add any kinds of visualization. So it's empty. So just I put the empty function, empty curly bracket, and put the name. I put the name. Suppose it's a study area. Study area. And now run the code. So now all of layer, also including the name, we are set the layer name. Study area, vegetation, false color, true color. Suppose I don't visualize the study area. Okay, this layer I just simply up. I don't display this layer. So how I can op it? So for the op, you can simply use the another function, another argument. It's called the false. Just I put the false. So when I put the false, what happened? So now this first study area layer is not open. So just run the code. So now I can see this layer is the unchecked. So now this layer is not open. Suppose you just make a big project. So in this project you add different types of layer, but all layers is not important. So then you can simply apply the false boolean operator false. Then it will be not showing. Suppose I just simply I don't open this layer. So just put here the false and run the code. So now this layer is not open. If you check, this layer is not open. Okay. So when I click, then it also open. There is no problem. But when I run this code, it just show only for the important layer. And when you use this type of argument, you can see I just use the E object, then visualization parameter, then name, then put the shown. This is another argument of this function. So then you need to put the sequentially, just put all of argument. Suppose in this case, you can see for this layer, for this ROI, there is no visualization, but I also put the empty bracket. It means that there is no visualization parameter. I just define it, the visualization parameter, then define the layer name, then define the shown. Okay, same process I just also apply. Suppose this is my object, this is my visualization parameter, this is the layer name, and this is the shown. True or false? Default is true, but when you put the false, then it not display the layer. Okay, so this is the process. Okay, so now I hope you can easily get the idea how we can easily work with single date imagery. Okay, single date imagery basically just for a specific time, a specific date. So this is the year of 2020, 11th February. This is the image. Same process you also try to check other imagery. You can see total 7 images in the list. So any image, just apply the same process and display. Just copy the ID, okay, and display the image. Okay, so it's called the single date imagery. So sometime we also use for monitoring for the single date imagery, but we can also use the another. It's called the composite. Okay, so now we talk about the composite. So when you work with single date, then just apply this process. And if you check lot of paper, they use the single date imagery. Okay, single date imagery benefit is that it's not we find out the proper spectral value or spectral signature or electromagnetic spectrum value is more perfect, we find out. But when you combine, suppose I have total 7 images, this 7 images is just combine and make the composite, so then we find out some mistake value also. So that's why it's better to use. And if you check maximum paper, so I'll show the one example. Maximum scientific paper, they are used at the single date imagery. Okay, not use the composite imagery. Composite imagery is neat when you work with big study area. Okay, suppose you want to work with big study area, single tiles or single image is not fully fill up. If you consider suppose Bangladesh, suppose I want to monitor for Bangladesh, whole Bangladesh area vegetation, so then single tiles is not enough. So if you check, simply search here, suppose I put simply search here Bangladesh path and row. So if you check in the how many tiles we need to cover the full Bangladesh, if you check this one, so for full Bangladesh I need 1 2 3 4 5 6 7 8 9 10 11 12 13 14. I need the 14 single images to cover the whole Bangladesh area. So then in this case, without composite there is no option. Okay, when you work with big study area, suppose I want to work with for full Bangladesh land use land cover, full Bangladesh LST, I need full Bangladesh vegetation. So then without composite we cannot create the image for the full Bangladesh, because single tile, suppose I take the one tiles, it just fill up only for this study area, but other place how I can fill up. Okay, so that's the region. So when you are working with big study area, then we try to use the image composite. But when you work with a small study area, suppose just let me show you that, then don't need for the composite. Okay, we can easily find out. Just a minute. So in this case, you can see they are used at the Landsat 5 imagery for the different season. In the summer season, they take this imagery. You can see 22 February 2000. Okay, and also take that 4th April 2010. Okay, and the winter season, they take the image 2 November and also 14 November. Okay, then same process, you can see, just check the specific date and make the analysis. Okay, because they are only work out for the Dhaka city boundary, so it's a small study area, so single tile is easily enough for my Dhaka city or any other small study area. But when you work with big study area like as Bangladesh or any other big study area, then without composite we cannot create the image. Okay, so now we talk about that how we can easily create the image composite, and there's a lot of way to create the image composite. Okay, so I'll try to explain all of those, then you can easily get the idea. And when you need the image composite, I hope you can also get the idea. So basically when you work with big study area and which study area single date imagery is not fully fill up or cover my study area, then we try to check the image composite. Okay, so let's go. So now I talk about that image composite. So image composite is creating by combining multiple satellite images of the same area into a single representative image. Suppose I want to display for my whole Bangladesh, I need the satellite imagery. Okay, So now I just use the multiple satellite image of the same area in Bangladesh into a single representative image. Okay, and so for I show you the practical example. Suppose for that I simply import my study area, or I just simply use the US device wave data set, okay, which provide the international country boundary polygon. So previous class I discussed about that. So from here I just take the boundary shape file of Bangladesh. So take a variable, I put suppose BD and call the table just filter. How I can filter? I want to use art engine dot filter dot equal what's equal what, country name is Bangladesh. So now Bangladesh boundary is stored in the BD. Okay, so I want to create the composite image composite for the whole country boundary of Bangladesh. So how I can do it? So for that, okay, just I call the Landsat. I just I use the same image collection also, no problem. Just I copy. And then paste here. Then give a variable name. Suppose I put the name is image collection. Okay. So now apply the same step for filtering where, how, and when. So previous time I take the image, I just use the different variable and take the different function, filter bounds, filter metadata, filter date. Okay, if you want without taking the variable, just use the one variable and also filter. Suppose how I can do it, just use that dot filter bounds and put the BD, it's my shape file, then take the filter date. So I take the image in year of 2020 or December, January to December 2020, December 31. Then I take filter metadata, okay, for filtering image properties. Metadata. Just put here cloud cover less than 1. But if you want, you can also use the another function instead of this function called the dot filter. How I can filter? Art engine dot filter dot lt less than, then put the cloud cover, your property name, and put the val 1. Okay, same. So this function deprecated, but now we can also use this way, there is no problem. Okay, same work. Okay, so now we find out the filter dates, filter date, and filter metadata we find out. So now let's check how many images are available. So print, call the image and use the size function and run the code. So let's compute it, how many images are available. So what is the problem? Oh sorry, cover. So you find out how many images. Let's check. You can see for the 1 year, less than 1% for the whole country boundary of Bangladesh is covered this image. So now this image we find out the multiple images, okay, for my study area in Bangladesh. So now I want to create the composite using total 67 images I use and make the composite. And when you create the composite, you can get some benefit. So I talk about the benefit about that, how what type of benefit we can get for image composite. Because basically, first of all, when you are using the composite, so I'll write it, then you will get the idea of benefits. The first benefit for composite, we find out the cloud free image. Cloud free image. Okay, when you are using the composite, so removing and minimize the cloud and shadow effect from your satellite imagery. Secondly, we find out that okay, it also help you to time series analysis. Okay, because it is a total 67 images, so we can easily make the time series analysis, LST, NDV, or others. But single date image only for the single image. Okay, so there is no option for time series analysis. Okay, then what the benefit we can find out. So it also help you to noise reduction. So noise reduction basically minimize the variation due to the sensor and atmospheric disturbance. Okay, different types of noise we find out in the satellite image. So it also help you to reduction this type of noise. So this type of things we can also find out in the image composite, and image composite can be two types. Okay, types of composite, types of image composite. So suppose we can say first type, it's called that suppose we can create the combine multiple image for the different time. Suppose monthly composite, only for the monthly composite. Another is for annual composite, annual composite. So in this case we just apply the annual composite because I take the 1 year, but we can also create a monthly composite, annual composite for others data set also. This is the two types of composite, and we can combine multiple images from the different time range, suppose monthly composite, annual composite, and we can use this. It also help you to trend analysis we can also do using this composite. We can also do for vegetation, it's called the vegetation phenology. We can also do vegetation phenology, or a lot of things, suppose drought monitoring. So different purpose we are using here the composite for trend analysis, vegetation phenology, or drought. Okay, so this is the opportunity to use the image composite. And another thing is that for the spectral composite, okay, spectral composite, what is the spectral composite? Suppose a spectral composite. So a spectral composite basically combine different band from one or more images from a multi-band image. Suppose in this time I have total 67 images. This 67 images have the each image have the bands. Okay, so all of images have the band. Suppose you can see I have total 7 images for the previous Dhaka city. So if you check all images, suppose this is the first image, and for this first image I find out the bands. Then second image I find out the bands. So every image it give me the multi band image. So combine different bands from one or more images to form a multi band image. So when I create the composite, it help me to create multi band image. Okay, it form multi band image. Okay, it from the multi band image. Okay, so this is the another things you can easily create all of bands together and create the multi band image. Okay, and it also help you to different types of statistical composite. We are using suppose a statistical composite. So what is the statistical composite? So now use the mathematical operation on pixel value across multiple images. It's called the statistical composite. And we can use the different common method. Suppose first method we can say it's a first method we are use suppose median composite. It's a one method. We also use another method, it's called mean composite. Third method we can also say it's a max composite. So median composite, what happened for the median composite when I apply median composite, median value per pixel. So per pixel it computed median values and create the composite. So mean composite per pixel it computed the average. Okay, so average value per pixel or mean value per pixel computed and create the composite, and max same. Okay, so we find out that, and maximum it calculate the maximum value per pixel. Suppose for this pixel, what is the maximum value it computed, and select the highest pixel value. So now suppose median composite have some benefit. So median composite help you to reduce noise and haze from your satellite imagery. We can easily remove. Then average it's help you to smooth presentation of your image, or smooth image we find out. And then finally maximum composite suppose for NDVI, it help you to find out the good for vegetation mapping. Okay, suppose when I apply the max, we can easily identify maximum pixel for NDVI. So we find out it's mainly highest NDVI pixel. When you select, we find out the good for vegetation. Okay, so we find out this type of image. I have total 67 images. So I want to create the composite. So I want to create the composite, suppose median composite. Okay, so you can say check it. Suppose this is my image collection. Okay, so now let's check the image collection data type. Image collection. In the image collection, we find out the median. If you check, you can check median, mean, max, all of those we find out in here. Yeah, suppose median. Click on the median. So what happened? So median, this function reduce an image collection by calculating the median of all values at each pixel across the stack of all missing bands. Okay, all of missing bands. Suppose this 67 images have all of bands, missing bands. Suppose B1, B2, B3, all of band missing bands, and bands are matched by their name. Okay, by their name. Suppose B1, B2, B3 by their name. So how I can apply? You can see I have a image collection. Just apply the median. Just copy the median, and median is an empty argument. You can see there is no argument we need to apply. Okay, and it returned the image. So when I apply the median, then image collection convert into image data type. So it's very important. Suppose I have a image collection, but in this image collection, when I apply dot median function, so now it worked as a image data type. So this variable work as a image data type. So now this variable image is not the image collection. It's when I apply the median, it show the image data type. Run the code, you can see we face a problem. With this problem, let's check. We face a problem. Image.size is not a function. Okay, and you can guess it. What is the problem in here? Why size function is not work for this code?
Because size is incorporated in the image collection, but we are using the image.
Yes,
Yeah.
yes. Size is only work for the collection, image collection. But when I apply the median, then this variable is stored single median composite image. So that's the reason it show this type of problem. Okay, so it's not work, because when I apply the median, then this variable is stored the image, single median composite image. So now after creating the image, we can easily apply the clip function. We already know about that. Just I simply use the clip function, clip, with my study area, which is BD. Okay, because when I create the median, it create the single median composite image, and we can easily apply the clip function on the image. Okay, we already know about that. So now just run the code. Just I add the layer. Suppose just I add the layer, map.add layer, and call image, and run the code. So now it added the another layer for whole Bangladesh boundary. It's a median composite. So we find out this type of composite without visualization. Now let's check the visualization. Click on here. Suppose I'm at the visualization, any band combination. I put suppose a near short of infrared one, then near infrared and green, just stressing 98%. And apply. So now it also, you can see, find out this type of band combination and this type of image. So these things I want to import, just copy this variable name and paste after the object name, and then I put the land name, suppose Bangladesh, true color. Now run the code. So now you can easily find out the image composite for the whole country Bangladesh. And now I can easily use this image for the different purpose. Suppose application. What the application I can do now? So now I can apply the application to monitor, suppose LULC mapping, land use land cover mapping I can do. I can also do suppose vegetation monitoring. Okay. I can also do for what can I do? I can do suppose climate studies. In here we can simply suppose annual. So this is the satellite data, but we can also get the climate satellite data also. So then we just create the composite and analyze the climate studies. Suppose annual temperature or precipitation. Okay, this type of thing we can also do, and also do for suppose disaster monitoring. So this is the monitoring. Suppose you can take the image pre and post flood or any disaster, pre and post, suppose landslide event. Take the composite pre-event and post-event, then also make the analysis. As well as we can also do for, what can I do? We can also do suppose time series analysis. So we can do a lot of things in the remote sensing. So this type of thing we can really apply. And the composite advantage, when you apply the composite, we find out the cloud free imagery, or it also reduce our noise. Okay, so I hope you guys get the idea how we can easily work with composite. So in this time I talk about only for the one composite, median. So median basically it compute the middle pixel value, median pixel value. Okay, as well as you can also try to apply suppose mean or max. Okay, as well as another is that we can also apply, so it's called that mosaic. So if you check some, click on here and check suppose what is the mosaic. So you can easily find out under this image collection section. You can see what is the mosaic. What is the mosaic? What is the mosaic? You can see max, median, mean, minimum, mosaic. Okay, so we find out the mosaic. So mosaic composite in remote sensing, it's very important. We can create the larger image from multiple overlay scene. Okay, suppose I have a multiple overlapping scene. Suppose for Bangladesh I find out that all of scene. Okay, some scenes are overlapping. Suppose these two scenes just overlap each other. So then I can easily apply the mosaic. Okay, and create the larger image from multiple overlapping scene or uniform visualization. Okay, uniform visualization basically remove image boundaries or gap between tiles. It also help you. Sometime you try, you can get the some gap in your satellite imagery, or you also get some boundary. Okay, image boundary. Suppose this type of, you can see here, we find out this type of boundary. It's a boundary, any tiles or any things. So mosaic is also help you to remove this type of boundaries or gap and also create the uniform visualization. Okay, so this is another opportunity to use the mosaic. Basically we apply for the multiple overlapping scene. Okay, And also it also remove the image boundary, because you can see every tiles have a boundary. Suppose when I open the single tiles, okay, we find out a boundary. Suppose you can see we find out it's a boundary line. Okay, so this type of boundary line easily removed from here, and also help you to cloud free images. Okay. So we also further we also discuss about this type of things, more practical example when I show you that. Okay, then you can get the idea. But this type of mosaic composite you can create in remote sensing. Okay. 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 Anyone in question, you can ask me for this filtering and visualization.
Sir, I had tried to composite my whole India map,
Yeah.
but still there is some gap remain.
Okay.
I have applied both median as well as mosaic.
Okay. So it's not fully fill up your study area. Some place there is no image. Yeah.
Yeah, some parts shows empty.
Okay, so you just simply increasing the cloud cover. Okay, it means that suppose for this type of place, less than 1% cloud cover image is not available. So you can simply increase, suppose 50% or 30%. Okay, then I hope it will work. There is no problem. But when you increasing this cloud level, then we find out some cloud scene on your imagery. So inshallah further class we will discuss about that, how we can remove this type of cloud from our satellite imagery. Then you can get the idea. So now we can simply increasing this value and then check what happened. Okay. Okay, just now we are make a break for 10 minutes, then we'll start again. Okay, just make a break for 10 minutes. Yeah. Okay, welcome back. Can you hear me? Hello. Hello, can you hear me? Okay, thank you.
Yes, sir.
Okay, thank you. So let me share my screen. I'm sure. Okay, so let's go. Yeah. Okay. So now I hope you can also get the idea how to work with image collection and how to filter the image and also how to display the single date image and also display the composite image. Okay. So now we talk about, okay, so you also try. So I also give you some homework. So you also try to do this using the same process. You also try for top of atmosphere for Landsat 8, Landsat 9 or others. You can see Landsat 7. Okay, just use this type of image collection for a specific time or a specific season or summer season or rainy season and display the image, okay, for the different year or different season. So just same process, just apply and then display for your own study area. Okay. So now we talk about the another product. It's called the MODIS. Okay, MODIS is another image collection. Okay, and MODIS we find out the different types of product. And we find out the daily product. You can see it show the daily, mainly temporal resolution is 1 day. It's called the daily. And we find out that some product, you can see all of those are the daily. So it provides a lot of information. You also try to read further later about the description, when you can get the idea who is data provide you his product, you can easily get. Okay. And basically in the MODIS we find out the different types of product. Suppose, okay, let's open a code editor. And MODIS we find out the two products. Suppose we find out the Terra and Aqua. Okay, two types of things we find out. Suppose two satellite in the MODIS. So first of all, MODIS is the short form, but this full form is that moderate resolution imaging spectroradiometer. Okay, is for a spectroradiometer sensor. Okay, and it's one of the most widely used instrument in earth observation. Okay, because it provides a lot of product we find out using this data. And MODIS, now this satellite, two satellite combined. Okay, MODIS is on board two satellite. Okay, so first one is for Terra. It's one kind of satellite, Terra. So it worked from your 1999. Okay, 1999. Another for Aqua, Terra and Aqua. So it was launched in 2002. Okay, so we find out the two MODIS is on board to NASA satellite Terra and Aqua. Terra basically work for the land surface, only for the land surface. Okay, and we also use for another one. It's called Aqua. It launched in year of 2002. We find out. Okay, so what is that? Can we combine two Landsat images to create a new one? And like Landsat that was available up to 2012, another one is about 2025. I want to have image. Can we create? Yes, yes, yes. It's very important. Okay, so we can easily create this type of things. Suppose this is combined. Suppose Landsat. You can see. We can also combine Landsat 9, Landsat 8, Landsat 7, Landsat 5. All of image collection we can also combine. Okay, and create the annual image composite. We can also create. There is no problem. Huh? So we can easily combine this type of things and we can create this type of things. Okay, suppose Landsat 8, Landsat 9, Landsat 7. So all of image collection you also combine and create the composite. It also possible to create. So let's discuss a lot of things step by step. You can easily get the idea. Okay. Basically, it's very important when you make the analysis for temporal analysis. Okay, it's very important. Suppose you want to 1990 to 2025. So you need the image collection. Suppose 1980 to 2025. Suppose each year you need the image. So then we need to combine Landsat 5, Landsat 7, Landsat 8, okay, or Landsat 9. We can easily combine all of image collection and create the image composite from this type. Okay, and basically Terra and Aqua, this is the satellite name. Okay, these are two satellite, and this satellite basically monitoring the MODIS. Basically it's the moderate resolution imaging spectrometer, and it's NASA 2 satellite combined with the MODIS. NASA 2 satellite basically Terra and Aqua. Okay, so Terra it launched this time and Aqua 2002. Okay, Terra basically it's provide the information for the land, only for the land, and Aqua it provide the information for the water body, some ocean color or ocean sediment. So these type of things provide this Aqua. Okay, this is the Terra and Aqua. We find out these two satellite it take the information for the difference. So we find out that you can see these are two satellite from the MODIS. We find out the two satellites Terra and Aqua, and orbit type basically sun synchronous. We find out near polar orbit. It's a near polar orbit, and revisit 1 to 2 days for the high temporal resolution. 1 to 2 days. Okay, basically you can see this product, it's the daily. Okay, so daily means that you find out the data every single day, we find out the data, or 1 or 2 days we find out. Some data is that 8 days. Okay, it's very good for the temporal resolution, is very good for this type of data. But Landsat, Sentinel, it's not much good for the temporal resolution. Okay, temporal basically revisit frequency. We find out that 1 day or daily or 8 day. Okay, we can easily find out this type of data. But Landsat 5 days already check this type of frequency. Okay, and we find out the resolution, different types of resolution in the MODIS. Suppose MODIS, this resolution it can be 250 meter resolution. We find out some data set. We find out that 500 meter resolution, some data set, or 1000 meter resolution. We find out this type of data. Okay, and MODIS have total 36 bands, spectral bands. Okay, okay, 36 spectral bands. And land use land cover MODIS is also possible. We can get the land use land cover also MODIS satellite, no problem. MODIS, you can see MODIS have the ready-made product for the land use land cover. You can see the data. Where is the land use land cover? MODIS LULC data. Or simply search here. Suppose I simply search MODIS LULC. Okay, or MODIS land cover. You can see MODIS land cover type yearly. Okay, 500 meter resolution. So you can also use this data to make the land use land cover classification. Okay, it's available from 2001 to 2024. You can also use this type of data, and you can easily, it's a ready-made data. Okay, ready-made data. You can see we can easily classify this type of class. So EVAR needleaf forest, EVAR broadleaf forest, okay, deciduous forest, mixed forest, closed forest, open forest, woody savanna, grassland, permanent water, cropland. So this type of class we can easily classify. This is one kind of ready-made data. So MODIS is provide a lot of product. Okay, suppose we can easily find out the surface reflectance, land surface temperature, vegetation. We can also find out that leaf area index. Okay, evapotranspiration, net primary productivity. Then suppose also daily surface reflectance. So it provides a lot of product. You also try to read this type of description, then you can easily get the idea. Okay, and there's a lot of application, suppose agriculture sector or climate studies or hydrology or oceanography, disaster management, land use, land cover. So there's a lot of application you can use in the MODIS. And MODIS advantage is that large scale studies. Okay, so MODIS is very helpful when you work with large scale. Suppose you want to make the land use, land cover for the whole country boundary of India or any big study area, then MODIS is work very well. But when you apply the MODIS in the small study area, then it not work better. Okay, because it resolution is not much good. Okay, so then we find out some in large pixel value. We find out the grid. We don't find out the smooth map. But MODIS is very work well for the large scale data set, large scale. Suppose you want to work with any big study area, then you can easily perform the MODIS. We find out the very good map. Okay, it's ideal for large scale studies. Okay, and it useful for time series analysis because maximum data set is available from 2000 to present time, all of data set. Okay, we can easily find out. But one problem is that this data set you cannot use a small study area, because small study area we need to use high resolution imagery. Okay, but this data we can easily apply for big study area. Okay, or large scale data. So let's go show you the one example. I want to work with one data set. Suppose anyone, I want to work with this data. So I'm going to use the data. This is the one kind of MODIS product. So this product is the 16-day temporal resolution and 250 meter pixel size. And from this data set, I got two products. If you check, I find out the one product, it's called the NDVI. NDVI, it's normalized difference vegetation index. In EVI, enhanced vegetation index. NDVI, this is one kind of index to monitor vegetation. And this is the another index. It also monitors the vegetation, but it also useful for the dense vegetation. Okay, dense area vegetation. And it's the normal NDVI. You can easily apply for any study area, no problem. So this is my one kind of product. This is the product ID. This is the product ID. And this product ID I can easily apply. Yeah, please. Yeah. Yeah. Any
Sir,
question? Yeah.
I have a study area that covers 51 square kilometer. For LULC mapping, which satellite data is
51
most 51 square kilometer?
square kilometer. Yeah. So you want to apply which satellite for the land use, land cover? Yeah.
Yeah.
Okay, so in this case, we try to apply Sentinel 2 satellite imagery. It provides the more better resolution. Okay, and you can also compute it pixel or cell size also. Suppose you have total 51 square kilometer area, so you want to apply suppose which image. So then we simply use the pixel size, suppose 30 meter. So 30 meter, how much area cover, or 10 meter, how much area. So how many pixel you find out. Okay, so if the pixel number is high, it means that it's a good resolution imagery. If the pixel number is low, it means that it's not the good resolution imagery. Okay, so for that,
So cannot I use Landsat imagery?
so you can also use the Landsat imagery. Okay, but for the better resolution, you can also use the Sentinel 2. Okay, because Sentinel,
Okay,
it's the 10 meter. Okay, 10 meter, suppose 10 into 10. Okay, one pixel size is 100 square kilometer area. It cover one pixel size. So now you can simply calculate it, how many pixel you find out in the 51 square kilometer area. Okay, so then we can easily compute it. Or for the more local, for more small study area, then we try to apply the drone imagery. Then we also make the land use, land cover easily. Okay. So now we find out this type of product, and this product available between this time, and we find out the resolution of pixel size is the 250 meters. Okay, 250 meters. And if you check NDVI EVI, okay, this is the band name for this product. So I just simply copy this snippet ID. Okay, every image collection have a snippet ID, and paste on your code editor. Just paste. Okay, just paste and give a variable name. Suppose I put the name is that MODIS data. So now this image collection, I need to filter. Okay, so how I can filter, we already discussed about that. Basically, suppose where you need the image, then how, and then when. So these three options. So here I need the image. Suppose I need the image for the whole earth. Okay, so for the whole earth. So I just simply skip this part, because this image collection is for whole earth or whole globe. We find out this data. Then how? So this image collection have a two band. If you check the band name, NDVI and EVI. So I should suppose NDVI. So for that, just use here that select NDVI. Okay, and now this is another opportunity to use the data. If you check this data set, I don't apply any image properties. You can see there is no image properties in here. There is no image properties. It means that this data is pre-processed data, and this data already removed. You can see the water, clouds, heavy aerosol, and cloud shadow is already removed from this data. So that's why image metadata or image properties we don't need to filter, because all of cloud, all of heavy aerosol, all of noisy pixel already masked from this data. Okay, so that's why when you are using this data set, then we can easily use this data, because it's not affect any kinds of cloud, it's not affect any kinds of cloud shadow, or any kinds of heavy aerosol is not affect my satellite data. So that's why it's very useful data we can easily use and get the very neat and clean satellite imagery. Okay, so now I want to use this data. So that's why you can see not need to apply any kinds of filter metadata function. Okay, not need to filter any properties. Then when I need the image, suppose filter, I need the image filter date. Suppose in year of 2020 or 2024, suppose January to December 2024, December 31. So now let's check how many images are available. Print, call the MODIS data, and apply the size function. So now it's computing. So now let's check how many images. 23 images. So in this case, for the 1 year, I find out the 23 images. Okay, for the 1 year, because we find out the revisit is 16 day. Okay, this data set revisit or temporal 16 days. So that's why we find out that 23 images. Okay, for the 16 days revisit. So 23 multiply, suppose 16, almost 1 year done. You can see we find out the 368 or 1 year. So for the 1 year, we find out the total 23 images. So now we can easily display the map. Suppose just use map.add layer and display the MODIS data. Just copy and run the code. So now it loaded. If you check, it loaded the NDVI map for year of 2024 for the whole world without color. Okay, so let's go try to add the color. So for the coloring, if you check, this data set have already some demo color code. Okay, just I copy this demo color code and then paste on this code editor. So now if you check, just I copy and connect with my object. Okay, this is the visualization parameter. So it show the mean max range of NDVI and also add some color code, color hexacode as a list. So this is the dictionary. Okay, this dictionary add mean max and also plate it of color. Now run the code. So now it display the NDVI map for the whole world. We find out this type of map. It display. So we can easily get where is the no vegetation, where you find out the dense vegetation. Okay, Amazon, you find out this type of dense vegetation, you can see. So this is the vegetation map in year of 2024 for the 1 year. But I don't need for the whole world. I need for a specific country or a specific boundary. So for that, simply upload your shape file. So I take the dataset from USDOS. Suppose just use this data and take my boundary. So I take the boundary, suppose take ROI, and I have to filter table filter. How I can filter at engine dot filter dot equal what's equal what country name and put here Bangladesh. Okay, so now this variable is stored at the Bangladesh boundary. So now if I just clip, suppose you can see now MODIS data is a collection, but when I apply, suppose just I use here dot clip and call the shapefile ROI and run the code, it shows a problem. This problem is the EE.ImageCollection is not a function. Clip is not a function because clip, we already know clip is work only for image. Okay, clip is only work for image, but now this MODIS data, this variable is stored the image collection. So now I need to reduce this image collection and make a image composite. So how I can make the composite? We already know about that. We can calculate the mean, median, or average. So just I put here, I compute suppose average NDVI. So just put here the mean. So now it make the average NDVI map. So you can see now clip function is not work. Why? Because when I apply the mean, this variable work as a image data type. So that's why size is not work. Size is only work for collection. So now run the code again. So now we find out that NDVI map. Okay, average NDVI map for year of 2024 in Bangladesh. I want to focus on my given study area. For that, just use here map dot add layer and ROI zoom level suppose 10 and run the code. Oh sorry, map dot center object. I want to focus map dot center object. So now it's focusing my given study area and make the NDVI map. We find out this type of NDVI map. So we find out this type of satellite NDVI map in year of 2024. Okay. So not only for that, you can put any country boundary in here. Suppose I put the name for Pakistan and run the code. So now it display the NDVI map of Pakistan in year of 2024. So this is the NDVI map of Pakistan. Okay. So then suppose I want to add for another country, any country, just put the name, it create. Now run the code. So we find out this type of vegetation, green color, indicating about the vegetation area. Vegetation, vegetation, vegetation. Okay. Or any country, simply write the name, it will work. Okay, so this is the vegetation map. We can easily find out. Okay, so we find out this type of vegetation map, but this vegetation map have a problem. If you check, suppose click on the Nespero tab and click on this map, so you find out this type of value. Okay, long value you can see. But if you simply search on the Google, suppose I simply search NDVI range. So if you check NDVI range, we always find out -1 to +1. Okay, this is the range. And high positive value indicating about the high, negative value indicating about the waterborne other things. You can get that. Okay, so this is the website, UHGS website. You can get the more better idea or theoretical part from the NDVI, the foundation of remote sensing phenology. So this thing, if you read, you can see we find out NDVI value range from +1 to -1. Okay, areas of barren rock, sand, or snow usually show very low NDVI values. For example, 0.1 or less. Then sparse vegetation such as shrub or grassland or sensing crop, we find out that moderate NDVI values 0.2 to 0.5. And high NDVI values approximately 0.6 to 0.9. It's a dense vegetation, okay, found in temperate or tropical forest crop and their peak growth stage. We find out the high vegetation. But in this case, for my NDVI map, we find out this type of range, 5911 for the NDVI value. It means that I need to rescale my NDVI pixel value. Okay, I need to rescaling the pixel value of NDVI to create the range of NDVI. So how I can rescaling this data set? I need to rescale. So for the rescaling, if you check the data set, they are already provide a scale value. If you check, this is the scale value for rescaling this data. So I need to use this scale value and rescaling my data. So then I find out the data +1 to -1. I find out the data. So now how I can use this scale value? Okay, so this scale value I need to multiply. I need to multiply with all of images. Total how many images? Okay, it's not possible to check without when I apply the min function. So I need to multiply all of images with my scale value. If you check how many images, so I'll show you that. So I have total for the 1 year. We find out the total. How many images? 23. Just check the images. 23 images. Okay, this 23 images I need to multiply with this value. This value 0.001. Okay, this value I need to multiply all of images. So now how I can multiply? For multiply, in this case, we are just create a function. Okay, we just create a function. This function help you to compute each image multiply with this value 0.001. Okay, so let's go create a function. Take a variable. We already know about the structure of the function, Python and JavaScript. So and I apply, suppose take a variable scaled NDVI equal sign, put the function keyword. I put the parenthesis and put the element name, suppose img, and put the curly bracket. In this curly bracket I put my argument. So what is my argument? I just use this element name and I just put my argument in here. So I want return this element. Return this element means image. Suppose this is my image. So I want this image I return and multiply with this value 0.0001. Okay, so I create this type of function. So in this function I simply define a element img Okay, this element I just simply return with this, multiply with this value 0.001. But I have total 23 images. Okay, I have total 23 images. So this 23 images I need to multiply, okay, all of images. But in this case I just take only for the one element. One element means one image I just take. But for the rest of the other images, we just apply another function. It called the copy properties. Copy properties. So it's copy the properties from this element, and this property apply from this time period, system time start to system time end. Okay, so just simply define system time start to system time end, sorry, end. Okay, so just I create a function. Okay, in this function I take the one element. So this element I want to return and multiply this value, and this property, after multiply this property I simply copy using the copy properties and apply between this time period, system time start to system time end, which is indicating this time period. And in this time period I find out the total 23 images. Okay, so this is my function. Okay, this is the function, and this is my collection. Okay, so this collection, so now what happened? So from this collection, 23 image collection, just input in this function one by one. Suppose first image input and multiply, second image input multiply, third image input multiply, fourth image input and multiply. So all of total 23 images one by one just input in this function and multiply 0.001. So this is my function. Okay, this function we need to write after the collection. Okay, just after the collection I simply write this function. So now this function I need to connect with my collection, because from this collection one by one, just suppose this is a tool or this is a tool. This tool just input one image, suppose first image, second image, third image, all of image, 23 images, and multiply this value. So this is my function and this is my collection. These two things I need to connect. So for the connecting, just call this variable name and paste here. Okay, this is my collection variable, MODIS data, and I want to connect with my function. For connecting, just use here the map function. Okay, so now this is my collection. So from this collection, one by one, all of images come in this tool and then multiply 0.001. Okay, all of images. So now if you check how many images are available in the scale NDVI, just copy and check how many images. We find out the same number of images, 23. But now all of images is multiplied with this value 0.0001. Okay, so now I just use this image, total 23 images I just use and make the average and compute the NDVI. Okay, so for that you can simply take a variable. Suppose I put the variable name is that mean NDVI. I want to make the mean NDVI using this scale NDVI images. Just copy and paste, and then apply the mean function, and then click with my study area, which is ROI. Okay, so now I want to display this NDVI layer. Just copy and I change it. Just I add the layer for now. Run the code. So now it show this type of result, because we also need to change the mean and max range. But for this map, I don't know what is the best value for the mean and max range. I don't know. So for that, simply click on this layer and then stress the data. Suppose put the stressing 98%. I keep it show this type of range. Just I copy and then simply copy max range. And now run the code. So we find out this type of NDVI map. So now let's check the pixel value. Just click on here, 0.6. So now we find out the reprojected NDVI value, which belongs +1 to -1. And now we also add the different color. Suppose I want to add the different color combination. Suppose I want to show the low NDVI value show as a blue color. Greater than, suppose put the white color. Greater than NDVI value show as a green color for vegetation. Now run the code. So I can easily find out, okay, this type of place have the water body, okay, and we find out this type of green color is the vegetation. Okay, you can check the pixel value, click. So then we check it, you can see 0.7. okay, high dense vegetation, we find out. Okay, find out, you can see low NDWI value, negative. Okay, you can see by pixel value is the negative, it's indicating about the water body. Okay, so this is the NDVI map we can create. So now this map further we can easily export. So now how I can export this type of map, in this time we discuss about that. Okay, as well as how we can easily export the satellite images. Okay, we already create some satellite images. So let's go how we can easily apply the export. Suppose this map I want to export. Okay, so when you export this map, then this visualization is not exported. Okay, it just exported grayscale color. Okay, grayscale color, and we exported the GeoTIFF file format. Okay, so for that we just use a function export. You can see we can export in our Google Drive. Okay, so you can see it also available cloud storage. Cloud storage, basically we can also buy the cloud storage, and this data we can also store in the cloud storage, also store in the asset tab. Okay, this tab we can also save our